On our contralateral hand, we have 3 accelerometers placed on 3 of the fingers, and we're reading the movement in the Z direction, the change. And so you can see on our display that it'll pick up the changes in the movements of the fingers.
Z1 being the index, Z2 being the middle finger, and Z3 being the ring finger. So as you can see, as each individual finger of hers moves, the Z's 1, Z2, and Z3 give you a different value for detecting the rotation of each finger.
Alright, so on our ipsilateral hand, we also embedded 2 buttons. So one button is to detect whether make our fingers stay in place. So if we grab an object and we don't want to release it yet, we can hold down the stay button and it'll keep the grasp on that object. And so on the display, you can see in the small corner it says stay, and if we release it, it says move. And then our next button is to slow down the movement of our fingers, and that's for fine grasping of objects, such as the cup. And we can hold that down and it says time for servos to move, and then if we release it, it says time for servos to move too. So when we press the button, it'll slow down the movement to 200.
20 microseconds.
20 microseconds. And then if we release it, it moves to the speed which we have for our accelerometers.
Which is, yeah.
The lateral hand, we embedded 3 limit switches into our fingers. And so as our limit switches are pressed, it'll detect whether we're touching an object. So on the display, you can see that we have correlated our index, our middle, and our thumb finger where we have our limit switches. So if you press one, it changes to index. The next one, instead of saying no middle, it says middle. And no thumb changes to thumb. And this means that we have come in contact with an object. Alright, so we've correlated our sensors, the accelerometers, to LEDs so that when you bend each finger, the LED will go off. So when we bend our index finger, our green LED goes off. We bend our middle finger and our purple LED goes off. And we bend our ring finger and the red and blue go off.
So here's our wiring harness. This is for the contralateral arm, and this is for the ipsilateral arm. On our contralateral arm, we have the 3 accelerometers and some of the haptic feedback vibrators within this strap that holds the harness close to our body. So from our accelerometers, we have small wiring harness that combine them together back into this larger one, and then we drive that all the way down to this board, which has all of the sleep pins, sensor pins for the X, Y, and Z, the power pins, and the ground pins. This ends up going here into analog read for the reading sensors, into analog 2, 3, and 4, and then the sleep pins end up going into the Arduino Mega into digital pins 2, 3, and 4. The next part being the ipsilateral arm. That wiring harness also has its own vibrating motors as well attached to it. The wiring harness for the ipsilateral arm drives down the wiring for the limit switches in the 3 fingers, the button wires, and the sensor driving wires, as well as the LED wires shown here. It drives it all the way down. So the motors are driven by this small what is it called? Proto board. Yeah, but this small soldering board, and then this drives the motors itself, and this one is by itself since the motors are driven by an external battery. Everything else is driven by the Arduino Mega battery power source. So this ends up going in like so to end up powering the servos. Over here we have another soldering board which connects all of the vibrating sensors for both the contralateral and the ipsilateral arm, as well as the limit switch wires, and then the LED digital pins and the button digital pins. And then I'll connect everything so you can see how everything goes onto the Arduino Mega board. And that's how everything ends up being wired together.
Accelerometers to control the movement of our hand. So when we bend one finger, it closes the index finger, and then we close our middle finger, and it closes our middle finger. We close our ring finger, and it closes our ring finger and our pinky. Alright, so for our second use of motors, we are using these vibrating motors to provide haptic feedback. And so we have them connected to our limit switches. So as our fingers come in contact with an object, it'll click the limit switch, which will cause our vibrating motors to go off, as you can see. And these are we have these connected to our upper arm. What is this?
Bicep.
Whatever, bicep. And they're wrapped around our bicep with this little band.
Where we could feel the vibration of the haptic feedback whenever the limit switches are pressed.
Okay, so here this motor is connected to our ring finger, and this motor here is connected to our thumb. Alright, so for our actuation method, we have Kevlar string that runs through the tip of our finger all the way back into our servo motors. So this Kevlar string wraps around these little pins here, just like a pulley would. We have two revolute joints for our fingers, and so as the servo motor turns, these fingers will bend, as so. Alright, and for our gripping, we have, we used hot glue, so we just made little strips that would go over our limit switches. We still need flexibility in them so that our limit switches are able to click. And then the rest of the hand is just laced with little beads of hot glue. Setup of all of our gear. We have the contralateral hand with all of our sensors on it, and then the little band with the motor, all tied into a backpack that goes around, and then into our ipsilateral hand with prosthetic on it. Alright, so we're gonna start with the task of picking up the balls. So as you can see, as a hold.
Did you just say behold?
I have the holes on the ball. Alright, so for the next task, we have a tiny cup full of water, and so we'll be picking it up and putting it down. So we have here, picking it up, putting it down. So I could serve you a shot of tequila if you want.